let's talk about caching. We've got a system that generates tiny URLs. At some point, there will inevitably be certain tiny URLs which are more frequently accessed than others. Let's say Mr. Beast makes a link to his merch store. Dude has like 200 million subscribers. More people are going to use his link than most other links generated by this service. So let's make sure our system gives priority to a link like that as far as how fast it'll take to perform a read. When we do a read, we take the short URL and look in our system for that short URL entry, take its accompanying long URL, and redirect the user to the long URL. Now, with these hot links, we want to make sure they're more quickly available than normal. The system shouldn't have to go all the way into the database to find them. So before going all the way into the database, our application servers can more quickly serve it up if it exists in some kind of cache. We can use an off-the-shelf solution like Memcached, which can store an object containing the long and short URLs. And using the Pareto principle, let's cache 20% of daily traffic, since we can guess that about 80% of the clicks to links in our system will be clicks on about 20% of the links. Let's say in our system we need like 70 to 100 gigabytes of memory to cache 20% of traffic. And since a modern day enterprise level server can have about 64 to 256 gigabytes of memory, we'll need 1 or 2 machines. Of course, it's a good idea to add redundancy here anyway, just in case we need a backup, or if we want to distribute some of the hottest URLs between multiple machines, say Mr. Beast merch link on machine 1 and Bad Bunny's OnlyFans on machine 2. So what happens when the cache fills up? A pretty reasonable policy is least recently used, where we use something like a linked hash map to store our URLs by hash, which will keep track of which ones have been most and least recently used. So how does a linked hash map work? It's similar to a regular hash map, where it uses a hash table for quick access to elements based on their keys, and this provides O of 1 or constant time lookup. But it also uses a linked list to maintain the order of elements. It preserves the order in which the elements were inserted or accessed. But this video isn't really about specific data structures, so I'm not going to go super deep into that. Now, there's a possibility of a cache miss happening. This is when the data requested isn't in the cache, so the servers have to go look in the database. When this happens, we take the data retrieved from the database and use it to update the cache and pass the new entry to all of the cache replicas. Now, obviously, this is all part of a much larger system design study, and it's worth it to do a deeper dive if this sort of thing interests you. Thanks for watching. If you have any questions or need clarification on something, leave a comment, and have a great weekend.